Welcome to Designing for the Least Capable, Most Important Device in Our Network. We are here today with our special guest on April the 1st is Francois Vergès. And he's actually a fellow kind of I gotta say Canadian. He's actually on the East Coast. I'm on the West Coast. But before we get into that, I'm going to actually pass the baton because I am your sidekick, Stu, and I'm joined by my ever so lovely host, Tawny. Take it away. And I think I have to go this way. She's up that way. There she is. She's up.
Well, actually, I'm actually excited. We've got Francois here, one of our ECSE instructors. We have a world-class group of individuals, and excited to have Francois here. But I will let Francois introduce himself. He does a lot in our community, just a little bit. If you don't know him, you should. Francois.
Yeah, thank you guys. Thank you guys for having me. I'm excited about this. You guys you're a great team to present the webinars. I always get good love watching you guys. So good job to you guys. Yeah, so my name is Francois Vergès. Yeah. My name is Francois Vergès. I'm originally from France. I live in Canada now, on the other side of Canada compared to Stu. I'm in Ontario. I work as a Wi-Fi engineer for a company called Synthio Networks that I have founded a few years back now. So I focused my time on working on different Wi-Fi projects, teaching as well. So I'm one of the instructors, like Tony said, for the ECSE courses. I also teach the MIST training classes as well for Juniper. So that's pretty much me. Yeah, I'm excited to be here today, talk to you guys about the LCMI. I also forgot to say that I co-host the Clear to Send podcast, right? Yes. With Roel Dionisio. So we try to publish, episodes every week, and we talk about Wi-Fi related topics. I'm sure we've talked about LCMI before, but yeah, so we enjoy doing that. So if you guys like Wi-Fi, if you like podcasts, you should check out the Clear to Send podcast.
It is a great
shameless plug, right? Yeah. But no, yeah. Folks, actually, it's actually kind of cool. If you're on the podcast, listeners as well, be sure to check that out.
All right. So before we jump into our topic, as you guys know, we do love our poll questions.
Yes.
Our question here, come on, be my friend today. All right. So of the coverage requirements for your least capable, most important device, what do you prioritize first for your design? RSSI, SNR, primary, secondary coverage, data rates. Thank you, Stu. Nice. There we go. All right, we'll give it just another.
I was almost on cue there, right?
That was perfect. All right, just a couple. All right, now let's look at interesting RSSI. Everybody puts RSSI first. That's good.
We ended that pretty quick there. Sorry.
Yeah. Well, I usually only do 30 seconds.
You don't do 30 seconds. Yes, you guys. So folks, on the next poll question, answer quicker. Yeah.
Yeah. The next poll question, we'll make sure we have a little more information. But so today, talking about least capable, most important device. Why does that matter? Why is that significant, Francois? Not to put you on the spot or anything.
That's not
well, that's why I'm here, right? No, when we talk about this, I always talk about the way we design Wi-Fi versus the way we design wired network, right? Mm-hmm. Usually the way we design wired network, we don't care too much about the client devices. We just need to make sure we have enough capacity in our switches, make sure that, we can deliver, we have enough capacity in the core network, and make sure we can deliver like 1 gig or even more today to the client stations that we're going to plug into the wired network. And if we do that, we know we're going to have no problem. We're going to have enough capacity, and the wired network will work well. On the Wi-Fi end of things, though, it's a little different. We really have to care about the client devices, because the client devices will drive our design, will drive the set of requirements we'll need to come up with a design that would work. So we really have to spend some time analyzing, which client devices will connect to our environment and understand their Wi-Fi specs, understand how we're going to use them, understand how they're going to be important to us, and so we can better tailor, the network, the Wi-Fi network for them to make sure they will work properly. The only issue is that it's very hard to make a Wi-Fi network work perfectly for every devices that we're going to have connecting to the Wi-Fi. So we have to pick one, right? And that's why we have the LCMI. I'm sure you guys.
And I think to the customer, they don't always necessarily know which one is the most important. They're just going to say, this is what we do. So it's our job. The onus is on us to be able to ask the right questions to understand, because, you know, some customers will know and are very knowledgeable and will come out and tell you, but not all of them will. And so as you start to ask questions, as you start to gather those requirements, you'll be able to identify what devices are critical for operation and functionality on their network.
Yeah, and one thing that's I was going to say one thing that's important in the LCMI concept is that you have two parts to it. You have the LC and you have the MI, right? So the LC means least capable. So the idea behind that is that you want to make sure that your design will work for the least capable Wi-Fi device. And if you do, it makes sure that the other devices should follow up and should have a good experience. But it's not necessarily always the case, because sometimes you could have a very crappy device that would require a lot from, a lot more APs than usual. And that could potentially create issues on other devices that are important for the business as well. So that's why we have the other part. We have the MI, the most important, because we also have to take into account which devices are most important for the business. And that's usually always where I start. When I talk to the customers, I always start to try to define, okay, which devices are important for you, which devices are critical for the business, and then they start to list it. And then you can, like you said, Tony, you can follow up with questions. Usually what I do ask is, what happens if this device can't work? What happened to you? What happened to your environment? And then they tell us, oh, we can't work if this device is not online. So then, this device is very important for them, very important for the business. So you can take that also into account when you decide which device is the LCMI. And in the slides, you'll see later on, I use the term elect, because usually that's what it is. You have to elect which device will be your LCMI. Sometimes you have some debate.
Well, and, talking about what is most important, that specific device is going to have design requirements, but you're going to have other requirements in addition to that for the network, right? And so understanding that you've got two different things that you're trying to work through to build one cohesive network that's going to work for everything, right? Because everything works 100% of the time for every device, right? That's how that works.
Yes.
Yes,
right. And the requirements is really important, because you're going to use it when you design, right? To make sure that you design against the requirement, make sure that the devices will have a good experience on the Wi-Fi. But if you think about it too, the requirements, you're going to use them for the validation as well. Once everything is installed, you're going to validate against those requirements. You might also do some troubleshooting down the road, right? Let's say you've installed the Wi-Fi network, and then 2-3 years down the road, they stop working. Then you can go back to the requirements and you can troubleshoot against these requirements, and then maybe figure out why it's not working. Maybe some of these requirements change in the meantime. And if these requirements change, maybe you need to adjust, or maybe you need to change your design as well. So everything is kind of linked together, right? So that's why it's important to understand the requirements, understand which client devices will connect to the Wi-Fi, so we can come up with the proper technical requirements, the proper RF requirements that we can use in Ekahau to do the design.
And folks, just in true Ekahau fashion here, we're talking about this stuff first, but we're going to actually get into some of the demos and looking at some of these things later, specifically looking at some devices and et cetera. And so we will be doing that just as an FYI. But before we get into that, let's talk about some best practices for the network. So you were talking about how you elect which device is LCMI. Walk us through that process.
So that's going to depend a lot on the environment. In some environments, for some customers, it's very easy. I would say, like, in manufacturing environment or warehouse environments, like, they know exactly which devices are critical. They don't have plenty. So you can very easily find or elect your LCMI. In some environments, it's going to be a little bit more complex. So the process that I would usually do is try to talk to the customer, understand which devices will connect. And when I say which device, I try to go to the detail of which exact model will connect, because most of the time when you ask the customer which devices will connect, they'll tell you, Well, any devices, right? So
Mhm.
it doesn't really help you much here to define something that's very technical, the technical requirement. So you usually have to drill down a little bit more, understand, okay, which type of devices, is it laptop, smartphone, tablets, and then they tell you, and then which model. And sometimes they have no clue, they have no idea. So that's when I try to see with them if they have some sort of network management system to their running on where they can actually get some information from. So sometimes I like to get information on what is currently connected to the Wi-Fi, and then have a talk to the customer on, how are you guys thinking of evolving the different client devices? Are you interested in introducing new client devices? If yes, which one, which model, and so on. So you can kind of establish the list of all the different devices that will connect to the Wi-Fi. Then once you have this list and once you have the exact model number and so on, you can go back and get the Wi-Fi specification for each of these devices, and you can kind of have a better sense of which one would be your least capable, right? For the first part of the LCMI.
Yeah, sorry to interrupt. I think that this is a really important step, and I think you've outlined this clearly, Francois, is having a discussion with the customer prior to even putting in new APs or whatever, is talk with the customer, understanding, like get an understanding of what they're trying to do, accomplishments, and then their devices. And as you talk, you probably you may come in saying, well, I'm going to be designing for a small wireless phone, and then all of a sudden you find out that it's more than that. There's like 10 other devices that just all of a sudden just come out of nowhere, right? And so I think it's really critical, and I think this is cool that you're talking about this now, because you'd want to the folks out there today is, engage in conversation, understand kind of the little nuances.
Yeah,
exactly.
Francois, I was going to ask, can you walk us through? So you were talking about how you identify and you're asking the customer. If the customer has absolutely no idea what model they're using. So for example, they're like, we use iPhones, but as we know, there's like version 1 through 12 plus XP and all of these others, right? How would you recommend to someone to go about finding what specific model number they're utilizing on their network? Do you have any recommendation, or is it just kind of guess and check? And
no, so the iPhone is a little different because most iPhones will run the same OS, the same iOS with the same Wi-Fi driver. So you can kind of get some of the same, I guess, expect the same type of experience from iPhone, except if they have hardware differences on the type of iPhone and the Wi-Fi specs, which could happen if you go back, previous generations. In this case, you could just, what I do is I usually rely on my customers to get that information. So I rely them to tell me that, what are we usually, and it's funny you asked that because I had the case with a customer a month back. It's like it's a factory, a steel factory, and they were using iPads everywhere. And the guy told me, we have just different type of iPads. So what I ask is, what's the oldest iPad you have? Can you tell me the oldest iPad you have on the floor? And then here I got my my least capable devices, right?
And to
So you could
clarify for
also do
some
it that way.
folks, just really quickly to clarify, LCMI is the least capable, most important device for your network, right? So
Exactly.
clarifying that.
Yeah. And so this is important. All the Wi-Fi specs, it's important for the LC part of it, the least capable. And then to find out the MI, the most important part, then that's when you have this discussion with the customer and trying to understand which one are critical for your business. What happened if those iPads are, you don't have access to the Wi-Fi, and then you can try to define and classify the devices that way. And then once you have all of that information, you can elect which device you think will be your LCMI. And I'm kind of glancing at the chat as we talk. I try to grasp as much as I can. But I can see a lot of discussion, which is great.
Yes.
And so folks, if you go back to the previous slide. Yeah.
Oh, sorry.
I wanted to say that this process is flexible. So you don't have to have just one LCMI for the entire building project, whatever, you could have different areas with different LCMI. You could decide to have different LCMI per frequency band. So I saw someone talking about IoT. You could say, I'm going to put all of my business applications on 5 gigahertz and have one LCMI for that. And I'm going to dedicate 2.4 for my IoT and have an LCMI for that as well. So that process is kind of flexible. You can also have, like I said, different areas, and we'll show that in our demos later on today. But that's flexible, and you can kind of tailor it based on the project or the customer you're working for.
Yeah.
And the two notes here, I think they're important because sometimes I have the questions, especially the last one. Some people tell me I have no idea which devices will come and connect to my network. I'm just a public network, right? Think about a stadium. Think about even a university, right? You don't know what students will show up with. So in these type of environments, you're gonna have to select one device and then work with the customer and agree with the customer that you're gonna design for that device, particular device. And most of the time, it's usually either like an iPhone or an iPad or like an Android phone, because in those public places, that's what you will expect people to show up with. But it's important to, even if you have no idea, even if you have like a BYOD environment, it's important to also have LCMI that you can base your design against and have some sort of reference point, so you can have a clear vision of what you're doing.
And folks, also, something that I think is really significant. Someone was asking about compromises that you make for other, capable devices. The answer is it depends. It may, the functionality may be similar. You may not lose or compromise any performance for the network. It depends on a lot of factors involved in that. And one of the other things too that I wanted to highlight is the guidelines that we get. Those are given from the vendors. The specifications for the vendors is what their device needs to operate. And we're going to walk through some of that and what that looks like here in a little bit. And I love that there are a lot of questions related to that. So let's jump right in and specifically talk about how we look at the device specifications.
And it's also something before we talk about that, a good side effect of having this, doing this work is that you have a lot of good discussion with the customers, right? And the customer kind of understand a little bit better what you do. And the good thing about that is that I had customers I've worked with in the past having changes in their network, and call me and ask me, when thinking of introducing this new device, do you think it will impact our, the design we've done? Do you think it's our new LCMI, and so on? So you kind of bring awareness to the customer as well, to the client, to your customers, and that creates better discussion as well between you and your customers.
I think that's great that your customers reached out to you on that one. That shows.
I feel good when that happens.
I know, right? Well done.
Awesome.
You're doing something right when your customers, hey, I'm planning to introduce a new device. Yes.
Yeah, I know. It's usually the other way around. It's like
right. You usually find out afterwards.
Like
right?
something's not working. Well, that's because you didn't tell me you had that.
You know what? That's actually a really good feeling, because you know that, hey, we're planning to deploy a particular device. What do you think? What's your thoughts? Before we go day 2, right? Day 1.
Yeah.
I can see people having fun with the LCMI acronyms in the chat.
They are, yes. And I think I tried to do an April Fool's joke on that one.
Right.
But I think that's important though, Francois, as you talk about this, and this is where coming into that trusted advisor, right? As you're building that credibility that the client has come back to you as a trusted, I want to do this, but understanding the complexities and the nuances of Wi-Fi and how it can be kind of interesting, right? Of how we can actually make things work. Cool. Because it's radios, right?
Yeah, exactly. No, that's really important. And also it makes it more tangible for the customers, Wi-Fi can be a little bit of a gray box sometimes for the customers. They don't really know. It's like, just make it work. But if you explain a little bit how it works and you have these discussions, they have a little bit better idea of how everything is supposed to work.
Absolutely.
Okay, so let's talk about the Wi-Fi specs. So how do you get Wi-Fi specification of devices? And that's a discussion I like to have when we teach the Ekahau class. Because when you go, the first place you would go typically is just look at the data sheet of the devices, So here you have a couple of pictures of iPhone and Android device. You could go to the data sheet and try to see what they support, but usually the data sheet will be pretty limited. They'll just tell you it's an AX device, and that's it. So, or AC device, and you will not get all the information that we actually need, to do our design, to do the RF design, and to do the capacity planning. If you're thinking of doing capacity planning. So what information are we looking for if we want to do the RF design and the capacity planning? So we're like looking at getting the the version of Wi-Fi supported by the phone. So that's the ABGN, ACAX, you name it. Usually that's not really that hard to get. Then we try to understand which channel width is supported by these devices to see if they might take advantage of us using 40 megahertz wide channel, for instance. Then we try to understand how many spatial streams they support, because that will help us to understand the data rate that they will support on the network. Then we try to understand the maximum transmit power that they support, and that will help us to define which transmit power we'll use on the APs to minimize the issues and I guess optimize the performance of these devices, of the LCMI. And then sometimes we can get the roaming threshold information. That's important to make sure that roaming work properly. And roaming is a big topic for customers. I'm sure everyone on the call here, I've heard customer complaining about my device don't roam, or my device stay connected, they're sticky, whatever. So looking at roaming thresholds, we can adjust a couple of things in our design to make sure that we can influence the client devices to roam when they're supposed to roam. So we'll take a look at that as well, but that's information that's nice to have as well.
A lot of questions about transmit power for the devices. Excuse me.
You have a question about that?
No, I was saying there's lots of questions folks are asking about
yeah.
transmit power for the devices. How do you know what the transmit power should be?
Yeah.
How do you
I
make
think
the
we have a
adjustments?
slide for that, right?
We
So
do.
we'll tease.
Was that a good lead in to the next slide?
Not quite, but almost.
Almost.
Yeah, so a couple of resources you can use. Vendor documentations, you'll get some information. We'll go back to vendor documentation because we have a wide variety of vendor documentations. We'll talk about it and talk about what we can find in there. You also have a great public database of Wi-Fi device specifications that Mike Albano built on his website. And he recently added a whole bunch of devices. I saw that last week. So I think he has close to 300 devices by now, and you can check a whole bunch of Wi-Fi stats, Wi-Fi devices stats, and it's a I guess a community-based website. You can also participate as well if you find devices that that you have on hand but is not on the website. You can add the data to the website. The profiler tool. I'm sure you guys have talked about the WNPi before on the show.
We have.
There is a profiler tool on the WNPi that helps you to profile devices, I guess, or to find out the specifications supported by different devices. And this is especially useful when you want to do a thorough analysis, because we'll see some devices, especially for the transmit power, some devices will not necessarily have the same maximum transmit power depending on the frequency band, depending on the channel. So if you want to do a thorough analysis on a device and understand exactly which transmit power is supported on all of the channels you're thinking of deploying on, then you can run the profile on each of these channels and do a thorough analysis of what the client supports. That's something you won't have, for instance, on Mike's website. Mike's website will just give you one maximum transmit power, but if you want to understand it per channel, then you can use a profiler. And sometimes you have some funny results. That's why I mentioned that.
Yeah.
And then the fcc.io, so that's another database you can search, and you can, it's public. You can search the results from the FCC testing. So when the FCC tests different equipment, they kind of take picture, they document, and they publish those results. And the fcc.io, it's kind of like an access to that database. And behind every devices, I have like I tested it yesterday. I have a Samsung tablet here, and at the back of it, if you look on the stickers, you have the ID, the FCC ID. You just punch it in the website, and you'll get the results. You'll see pictures. I always look at the pictures to make sure I'm looking at the proper device. And then you can see a report. They'll tell you which frequencies. I use it to find out which frequencies are supported and the maximum transfer power on these frequencies.
That is a great tool to use. If you,
yes,
yeah, definitely the
to find
FCC
it, yeah.
IO. That's actually a really a quick one to look at.
Yeah. So let's look.
And sometimes
at,
I've had just funny fact. Sometimes I had a vendor data sheet saying that the device was phone for only, and then I go on the FCC website and it says it's dual band. So sometimes you have those differences, and you wonder, okay, is it really?
It was at the time of filing, right? So maybe they had to change something at the time, right? Nope.
Exactly.
We may be able to turn it on later.
Yeah, sometimes you have to go deeper, and sometimes you have to contact the vendors, or to go on their support website, create an account, open a ticket. I've had to do that in the past to kind of get the final answer,
Mm-hmm. Yeah, it's challenging. So let's talk about vendor documentation, though, and where it comes from, because every vendor provides you everything you'd ever possibly need, right? In a pretty bow, wrapped it up. Here you go.
That would be perfect, right?
Right.
Yeah, so that's what we're expecting from the device vendors, is that they tell us, what which requirements we're supposed to design against to make sure that they have a good they operate properly on the Wi-Fi network. And don't get me wrong, some of them do. It's just that they do it in their own ways, and it's not something that's standardized. So sometimes we kind of have to do some research and to dig out the information that we're looking for. And it's sometimes not clearly outlined. It's not very explicit that, this value would be the minimum RSSI, this value would be, the minimum secondary RSSI, and so on. So sometimes we can have to do some research and dig out that information. And I guess that's some of the reason why we wanted to do this webinar also, is to kind of, showcase a little bit the process of going and getting that information out, and try to showcase sometimes some of the issues we can run into. Something you will see that different vendors like to use different naming for their documentations. So the documents in which you will find these type of requirement informations, they have different names. I try to list them here: deployment guides, implementation guides, best practices guide, infrastructure guides, and so on. So sometimes it's, one simple Google search will not necessarily lead you to the perfect document. You might have to do multiple researches. You might have to look on the vendor website. You might have to look on the support website of those vendors to try to dig out the documentation you're looking for. And what I like to do is when I find the documents that I think is good, I like to open it and do a quick search. I do a quick search on DBM. If I don't see anything, I close it. I know it's not the right one. So that's the first thing I do, search on DBM. If I see stuff, I start to see stuff, I'm like, okay, interesting. I try to see if I find the information I need, and then I start to look for roaming threshold, SNR, power, or transmit power. But some vendor likes to call it transmit power or the TX power. So you kind of have to be careful with your searches as well. Make sure that you do it thoroughly to find the information that you need.
Yeah, because a lot of vendors don't use the same terminology associated with the particular application or the particular item you're looking for.
Yes, exactly. So that's something I like to do to kind of find information. Sometimes this documentation is not public. I've had the case with the vendor where I had to actually open and create an account on the support website, but I couldn't create an account if I wasn't a partner. So I had to open a case and tell them that I was pretty much telling them what I was doing. And then they granted me access to their support website, and then I could download the proper document with the documentation. So it's not always straightforward. Sometimes you have to work your way through. Sometimes you might have to communicate with them to get the information, but usually you can find the information. If you search, you should find it.
And also I've seen a lot of folks in the past who have asked on Twitter or other Wi-Fi pros, ask community, hey, has anyone ever done this? Anybody have any vendor documentation on this particular device? I've seen that a lot as well.
And vendors have actually been starting to get better at this process.
I think so.
Over the last couple of years. I mean, we're seeing folks that are from the even our own ECSE program, the CWMP program, the CCIE program, where we're seeing a lot of that in those companies now. And they're like asking those questions so that the folks that are actually making those products are actually, hey, you know what, in our Ekahau design, we need to know what that is, right? So we can do that. Oh, well, maybe we should document that. And so we're starting to see more traction. I think that communities become more educated now. And as we do, even webinars like this, where we're trying to kind of get more out there, right? And as you say, it's the information is not always clearly outlined, right?
Yeah.
But it is getting better.
And some devices, I'm thinking about hospitals. Some companies, when they sell devices to hospital, they tell them, if your network is not meeting those specific requirements, we're not going to sell the solution to you, or it's not going to work well. And then they ask you, can you just prove that your current Wi-Fi network is meeting those requirements? So then it will clearly list out the requirements, which is nice. And then they tell, if you cannot prove it to me, then I have to go in and do a survey and charge you for it, of course.
Or you have to grab the device and test it yourself, right? You got to
yeah, exactly.
your own testing.
Yeah.
Sometimes it comes down to that, right?
Yeah. So I mean, in those cases, it's great for us because we will have all the documentation clearly outlined. So we have all the requirements. It's a little harder when we're talking about stream mainstream. That's the word I was looking for. Mainstream devices. We'll talk about these guys, but it's a little harder when you talk about mainstream devices. Yeah.
And what do we do with all of that? I mean, what do we do with all of that information? We put it into our requirements. We drop it into Pro.
Exactly.
And you can build your own profile for each one of those devices.
Exactly. I think a couple of slides back, we had the sentence at the bottom that said that the LCMI will drive the requirements. And that I should have put this sentence in red because it's very important. That's
we could highlight that.
Yeah. So what's even important here, right? I mean, this is, a really slick thing on the building the requirements. I mean, one of those things is that little box down at the bottom, right? I mean, that little box out of the check bar, apply the criteria to both bands, because I mean, Francois, you and I know well that not all devices play the same, right?
Yeah.
Yeah, exactly. So that little box at the bottom is great. We'll talk about it when we do the demo, but it allows you to have different set of requirements for 2.45 gigahertz. And sometimes you might have, like we talked about it earlier, you might have different LCMI for 2.45 gigahertz. So that gives you the flexibility to actually do that in the software.
And understanding you don't have to have one set of requirements for the entire project. You can have multiple requirements for different areas, for different devices, for different bands, warehousing, versus enterprise in the same location, in the office space versus the, the actual storage or warehouse facility, manufacturing, all of that. You can have multiple requirements. So that's why it's really good to build those profiles in there so that you can ensure you've got everything covered the way you need it covered.
Yeah, exactly. And what we have to do at this point is to kind of translate the information that the vendors are giving us into these requirements. And I guess that's what, we're going to try to do with the demos.
Yep. So let's look at transmit power, because we've got a lot of questions about transmit power. How do you know what adjustments to make? How do you know which to choose? So let's talk about that.
Yeah, and transmit power will come, in the process of designing something in Ekahau. I guess the first step will be defining your LCMI and then creating your coverage requirement profile, and then creating, I guess, your floor plan, your areas, assigning your profile to your areas. And then at one point, you're going to start placing your APs. And then you're going to ask yourself, okay, what's, what the height of my AP, and which transmit power do I want to use for that AP, right? And so what we want to try to look at is, the LCMI, the maximum transmit power of our LCMI. And a general rule is to make sure that we don't go above that maximum transmit power, because you could create asymmetric transmissions between the clients and the APs. And some issues can occurs if that happens. You can have sticky clients. You can have retries, because the client can hear the AP really well, but when he answers, the AP can hear the client. So that can generate a whole bunch of issues on the Wi-Fi. So to try to avoid that or minimize that, we try to make sure that the transmit power we use on our APs doesn't exceed the maximum of what the LCMI does. And usually, the vendors will tell us what the devices can support. And here I put out some examples from Zebra, Ascom, and Vocera. And they tell us, if you read, they tell us, what they support, which is great. One note I would make there, though, is this is the maximum transfer power. It doesn't mean that the client devices will always use the maximum transfer power. Most of the time, those devices are mobile and they're trying to conserve battery life. So you don't really know for sure, which type of power they'll use. Sometimes you can fix it, so you can configure it to whatever you want, but most of the time it's kind of fluctuates based on the device and how they've configured it. So you're not sure that it will always use the maximum transmit power. So sometimes, depending on what I do, sometimes I like to give myself a little bit of a buffer. So instead of using the maximum transmit power, I'll give myself maybe a 3 dB buffer and use that for my APs to kind of prevent, I guess, some issues and make sure that I don't burn out the battery of the devices as well.
Mm-hmm.
I don't control it, but I try to optimize it. That's what I'm trying to say. Yeah.
Well, I think that's what the direction it is you can't always control it, but you can do everything you can to optimize performance.
Yes. And something to note here, but I've already mentioned it, is they don't give you the details well, it depends on the vendor, but sometimes they don't give you the details per frequency band. So you have to go and get that information.
Yeah, absolutely.
Yeah, so that's pretty much what I do. And then I'll use that transfer power in my design.
Awesome. So we're going to take a look here actually at some of live demos. But before we do that, I want to ask, let's get that launched. What is the most important piece of information to present for a wireless design proposal? Select 3 choices. Stu, our lovely music.
Should be cute.
There we go. All right. And because this is a multiple choice one, we'll give everybody a little more time on this one.
Yes.
But before we jump into the demo, I wanted to share the results here. Quite a variety. Lots of folks, interoperability with the current infrastructure and budget seem to be leading that charge.
Some interesting responses. Yeah,
quite
right?
interesting. I would have thought personally, man hours, person hours. It impacts the ability to do it, because if you don't have the resources to do it. But let's get into some of the fun stuff, the things that we like to do.
I'll do it for them.
Yeah, hire Francois. That's the message here, right? And let's look at the fun stuff and the things that we want to look at. So we're going to do 2 demos here before we transition here for just a second. So the first one, we're going to look at utilizing the Cisco 8821 phones in a small clinic, voice over IP. And then number 2, we are going to look at an environment that has multiple coverage requirements, because there's multiple LCMI devices in the environment. And so I am going to let Francois take that over
And
here.
while he's switching, I have an old 7920. I mean,
oh, nice.
Yeah. I don't have an 88, or that would be nice. I do love that phone. But this is an old workhorse. It did well in its day.
Yeah.
It's really good.
Right.
It's still used a lot. I see it out there a lot. Yeah. So 2 demos. Tony, you let me know if I run out of time.
We're good.
We're still good.
So the first one is, like, I guess, a simple demo. One set of requirements for the small clinic we're going to design for. If you guys have attended the ACAC class, you might remember. I hope you remember this floor plan.
Very, very well.
And the reason why I wanted to show you this one is because the vendor documentation from Cisco is pretty good, and we can actually get all the information we need. So that's the first example. In the second example, I wanted to show you an environment where we actually have 2 different set of requirements, 2 different areas. So we'll work with a warehouse and we'll have two different set of requirements we use in the warehouse space and in the offices that are attached to the warehouse. So we can actually define two profiles, and I can show you in Ekahau how we can assign different profiles to different areas and design against these requirements, these different set of requirements. So for the first example here, I've kind of prepared the document. As you can see, I've scaled the floor plan, I've drew the wall. And what I want to do at this point is create my requirement profile. So I can go to project coverage requirements. And here, as you can see, we have like a couple of, default requirement profile that Ekahau has when you install it. But what I like to do is I like to create my own. So I'll click on add, and here you can change the name. So in this case, we're gonna design, what did we say? The Cisco phone, Cisco 8821. And then we're going to have to come up with those different requirements. We're going to have to understand, okay, what type of signal strengths do we have to design for? What type of secondary signal strength and so on? And to find this information, like we've talked about today, we have to go back to the vendor documentation. And Cisco has, let me just go back to my files. Cisco has a document here that I'm going to open. And I'm going to go back all the way to the top. This document is called Wireless LAN Deployment Guide for the 8821 and 8821-EX. So it sounds like the perfect name for what we're trying to do, which is great. And in this document, Cisco will detail everything we need to know on how we can design, Wi-Fi for these guys to operate properly. I've put, if you guys are interested, we can put the link to this document in the chat. So you can actually download it yourself.
And we can provide the links after the fact as well.
Yeah, sure. Yeah. If they send me 1 Bitcoin, I'll provide it for free. So what I've done before the show is I've created bookmarks where, I had interesting information. And they have this section called Wireless LAN Design. And here they're giving us information, right? So here they're telling us 5 gigahertz is the recommended frequency to for this phone to operate properly. So good, we know that we're gonna have to design on 5 gigahertz. And also, we also know that this phone supports 5 gigahertz, which is great. Here we have a little bit of information on overlapping, and they're giving us, percentage of overlap, which is not very useful for us. Keith has wrote a really good blog article on overlap. So it's not really practical for us, but what we like to do is try to understand the secondary signal strength, so we can make sure that in the real life we'll have overlap between our Wi-Fi cells. And to do that, we'll look at the secondary, and here they kind of tell us, make sure that you have at least 2 access points available with minus 67 dBm. So here they're giving us the threshold for the secondary signal strength. That's pretty much what this is. If I keep going down, they're giving us information on channels. I go fast. I have another bookmark here, because here at the end of the page, we have a signal strength and coverage. And here they're telling us that, we would expect a minus 67 dBm or higher on 5 gigahertz or 2.4. So there I have my signal strength requirement. Okay. So I can take this, I can go back to my Ekahau, and I can set my signal strength to minus 67 dBm. I can set my secondary signal strength. So you guys remember what it was?
I don't.
Minus 67.
Sorry, I'm muted.
So I can. All right,
keep going.
Yeah, so that's right there. I already got my signal strength,
Duh.
my secondary signal strength. And here, if I look at here, they're telling me the SNR, minimum of 25 dB. Okay, so this one is kind of a no-brainer. I can just save my SNR to 25 dB. And then for the data rate, I can go back to my documentation, scroll down. I have another bookmark. That's not this one, the last one. And in this bookmark, it's actually a section that they call data rates. And then if you scroll down, and you can actually read the information. And by the way, I invite you to read the entire guide. It's very good information.
I also agree. Yes.
Yeah.
Yeah.
I'm just highlighting different things here so we can go right to the point. But if you read everything, it's much more valuable than just looking at me browsing through the document. But here I can see that, they recommend a data rate of 24 megabits per second. Perfect. So I can go here and say 24 megabits per second, right? And at this point, that's pretty much all I need. For the channel interference, it's a good practice to always make sure that we set 1 to -85 to make sure that we don't generate too much co-channel interference, and we can actually measure at which point we start having co-channel interference. And at this point, I'm pretty much done. What I can do here is click on the make default. And what does this do? Stu, you want to explain what that does?
Well, now that anytime we start that our project on this end, it's always going to show up with that as a default for us.
Exactly. So now when I go back and define my coverage area with this little
any
tool,
new areas, yep.
It's gonna all.
And this is this is a really important feature, folks, is what the steps that Francois has just done is to do that and then get your area set. And then that'll automatically place the correct in there for you. So this is a really important step.
And then so here I've defined my area, and you can see at the top I have this little drop-down menu, and you can find all of your coverage requirement profile here. And then because I made this one by default, this is the one I have selected. And I know that now I can design against those set of requirements, right? In this environment as well, we know that we would want to design for 5 gigahertz. And now I can start placing my APs. So I'm going to go and get an AP. I like this missed AP. But then on my AP, going back to the transmit power, I need to configure my transmit power for 5 gigahertz. I'm actually going to disable 2.4 so we can simplify a little bit the process here. I need to adjust this value here based on the maximum transmit power of the LCMI, which is the Cisco phone right now. So once again, I can go back to my documentation, and here I have this section here in it's called the Wi-Fi section with specifications, and you can see how they're detailing the maximum transmit power depending on the version of Wi-Fi you're using and the channel width. So that can also impact the maximum transmit power. So depending on what I want to do, I can just look at these values. Here it's pretty consistent, 14 dBm, 13 dBm, 12 dBm here if I want to use AC, 12 dBm, 12 dBm. So what I will do is I will look at this and maybe take the minimum to be safe, right? 12 minimum. And then I can, set this to 12 dBm. Boom. And then once you have, one AP that's going to configure the way you want it, you can kind of continue and place your AP and start designing, to make sure that you're meeting your requirements.
Yeah, it doesn't take as many APs on that one. I think everyone discovers in that ECSE class.
Yes, but I'll show you. So we have to look at secondary signal strength, right?
Yes.
So I'll add a couple. Maybe
that's where it comes into play, right? It's like, do I have enough coverage in an area when another AP fails?
So we're getting close to our time. So I want to make sure we have enough time to get through that second one to show folks.
Absolutely. Lots of info here today. Lots of info here today, folks.
That's good. That's a goal. Anyway, green map. Green is good. We can move on.
Green is good. Yes.
All right. So I'm going to move on to the second example. Do I want to save this one? No, it's okay. Okay. So second example, we have this warehouse, with two different environments, the offices and the warehouse. And the particularity we have here is that we have two different important devices depending on where we are. In the warehouse, the important device, so the LCMI, is the Zebra scanner. And in the offices and lounge, the important device is the iPhone 12. I think I picked.
Yes.
So then now we have two LCMI. So I have to go back and create two requirement profile. So I'm going to add one for the Zebra one. TC77. And also what I didn't mention here is that, in terms of application with the Zebra, they're going to use it to scan, but also to receive calls and orders, so it's important to also support voice.
Right. And voice,
so we have this guide. Yes, exactly. And then we have this guide from Zebra that's called, let me close this guy so it's a little cleaner. It's called voice deployment for, so here another name for the document, voice deployment for the different devices, and it includes the TC77 we're deploying for. And if I look, down in this document, I have this network settings and device RF characteristics, and it's giving me the information I need, right? It's giving me the minimum signal strength, which will be -65, the minimum SNR at 25. Here they're giving us some information related to the co-channel interference. They want us to have at least 19 dB of separation between APs operating on the same channel. They're also giving us 20% of channel overlap. And then they're giving us a channel that they would want us to use. And if you notice, it doesn't include the DFS channels, but they do tell us that DFS are supported, but we have to, be careful about it. At least you have the information here in this document. And then they also give us the roaming threshold. And the roaming threshold is something that's important because it tells us at which point the device will start looking for a new AP, right? So for us in our design, roaming, we kind of have to link roaming thresholds to the secondary RSSI. That's pretty much what the secondary RSSI is for. That's what Stu was mentioning earlier. We want to make sure that when the AP is starting to look for another IEP, we want to make sure that we are providing another IEP with a good signal so that device can roam fast and we can have a smooth roaming experience between our IEPs. So the roaming threshold, we could use it here for our secondary signal strength, okay? And that would just guarantee that when one of these devices is looking for a new AP, it will find it. It will find a candidate to roam to. Let me see if I had other bookmark. Yeah, I had another bookmark here, 5 gigahertz for voice. And it gives us a little bit information on the data rate as well.
And you know what? That's the best. Sorry, that's the best little nugget that I saw right there. Note: do not use weapon TKIP.
Yes.
I tell you, that's going to be the. I'm so happy that they put that in that document because that's a golden nugget right there for folks to say, hey, please don't, because there are places that still use that, strangely enough. So, but I think this is what's really important, is that you're outlining that understand the capabilities of the client, understand what you have to do to get here.
Yeah.
Yes. And so now I can take this information and then go back to my Ekahau, right? Just like how we did for the Cisco phone. So -6, the signal strength I think was -65 dBm.
65. Yep.
Secondary was -65. So this means that everywhere in our environment, the Zebra devices will have to see at least 2 APs with a -65 dBm threshold. SNR was 25, if I recall properly.
Yes.
Data rate, I think they had 12 at the minimum.
It was.
For the data rate, I don't worry too much about the data rate, because if you provide a good SNR, the data rate will follow, right? So I focus on the SNR way more than the data rate. But yeah, if you provide a good SNR, the data rate should follow. And then the channel interference will always be the same. So I can put it back to this, and then I can make it default, and I can add another one. I'm going to add my iPhones.
We've got just 2 minutes left here as we go through. So folks, we'll make sure we get through this demo so we can highlight that.
Yeah, no problem. So for the iPhone, same thing. You can try to go back to the vendor documentation. And that's when it's not going to be as straightforward as what it was with Zebra and Cisco here. We do have a document here on the website. No, it's not this one. I'll get to that one. It's this one. So it's actually on the support website. I just printed it as a PDF, but you can go on the support website and you have this article. It's called About Wireless Roaming for Enterprises. And it's giving us a little bit more information on how the device roam. So we can understand, what they call the trigger threshold, so the roaming threshold. And it's also important to, it's also nice because we can understand how different devices will operate. The iPhone will operate differently from the Zebra device, for instance. because the iPhone will have a roaming threshold, which is -70 here. So when the signal of the phone receives a signal of -70 or lower, it will start to scan and find a new AP to roam to. But then on top of that, they also have a delta. So if you scroll down that document, they have this section that they call Rom Candidates, and they're telling us that they will pick a new AP if the RSSI is 8 dB higher than what they currently have. Okay, so when they start roaming, it doesn't mean that they're gonna when they start scanning for a new AP, it doesn't mean that they're gonna roam right away. If there's no candidate with a good enough signal, they're just gonna stay where they are. Okay, and that can actually introduce some delays. So what we want to make sure is we want to make sure that when the phone starts roaming, we provide an option, a new AP there with a proper signal, so the phone can roam to. And in the document, we don't have time to go in details in the document, but if you go back at the top, they kind of give you the thresholds. They tell you to use a primary signal strength of -65 and a secondary of -67. If you use this value, you can comply. They bring it as an example. Yeah.
Go ahead.
No, I was going to say they bring it as an example, but that's the values you will find in other documentations as well from vendors, from AP vendors.
And you can see the 3 different ones we've shown, how different they are. It's not the same, and it's worded different, presented differently. So that's something also important to remember.
And here, if you look just as a document, we don't have information on SNR. We don't have information on data rate and all of this. So what you can actually do is couple that information with other documents from your AP vendors. So Cisco actually collaborated with Apple, and they came out with this guide that's pretty nice. That's called Best Practices for iOS Devices. And in this document, you will find a little bit, in a more explicit way, the information that you need to define your profile. So here we can see -65, -67, at least 2 AP at -67, 5 gigahertz is better, and then SNR of 25 dB. Right. So I could go back to finish off here. I could go back and create that profile. The data rate, I'll use 12 as well. And then here I'm going to add, I'm just going to close. And then what I can do is I can go back to my areas. I'm going to create an area for my warehouse. Made a mistake, and just do undo.
I mean, that's totally a lot of information here today, folks.
Yeah.
And I hope that as we've gone past the hour here, a couple of minutes here, but I really appreciate you sticking on here just for a couple more seconds here as we on the recording. But actually, while we're going through this, should we kind of cut in some final thoughts there, Tony? What do you think?
Yeah, I think it's just really, it's just important to understand what the devices are. And that's why it's so critical, is to understand what the devices are, where you can go to get that information, and how you can set it up. Because as Francois was walking us through, you can have multiple important devices. You can have all of these different coverage areas that you're creating. And so what you can really do is really get the highest reliable network, because you can really account for all of those different things. And so it's important.
I was trying to, I have a Zoom that gets in the way here. I was trying to, oh, here you go. Yeah, so here what I was doing is pretty much creating different areas. I like to change the colors as well. You can do that in Ekahau. If you go to the advanced menu of the area, you can change the color. I use my daughter's favorite color here. Offices, and then here I've assigned the iPhone profile to the offices and to the lounge area. And I have assigned my Zebra profile to the warehouse. And that's how you do it.
Awesome. Thank you, Francois. Folks, I know we kind of rushed through that at the very end, but as you can see, the 2 different separate areas with the 2 different coverage requirements. Francois, any final thoughts as we wrap this up? And I'm going to go ahead and share so that we can volunteer Francois to answer any additional questions or anything that you have the questions that you guys have on Twitter, he would be more than happy to reach out. But any final thoughts, Francois?
Yeah, I think what's important to we briefly talked about it, but you know, Wi-Fi network is something that evolves all of the time, and the client devices that we're gonna connect to the Wi-Fi will also evolve over time. So it's important for the customer to understand that. So when they're introducing new devices, they can kind of ask themselves, is it gonna be our new LCMI, and how is that gonna impact the Wi-Fi we have today? Do we have to reassess what we have? Do we have to redesign in the worst case scenario? And how we would make sure that this device will have, will operate properly on the network without impacting what we have today. So that's also something to keep in mind, because it's an ever-changing, environment, I guess. So it's something that's nice to keep in mind.
Absolutely.
All right. And with that, well, let me just give a quick closeout here. Again, I am your sidekick, Stu, and obviously my my host and co-host, Tawny. And thank you very much, Francois, for joining us today. And that is a wrap for designing for your least most capable device for April 1st.
Yes.
All right. And thank you very much, folks. And that's a wrap.
All right.
Thank you.